Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue learning about pandas. In previous video we talked about ranks, and in this video we'll move a step further and look at windows and window functions. So specifically we'll talk at cumulative, sum, products, min, max, and we'll also look at the rolling windows where we can specify what would be the window type. But before we start coding, let's look at some examples. Here we are going to do a cumulative sum. So I have a table with a column A which has 4 values 1, 3, 2 and 5. So when we do a cumulative sum, we could assume that this is more like a one window, because we are adding, in this case there's no value above it, so we just have one here. For the next one we are going to add this one with this 3 to get a value of 4. After that we are going to add this 4 with 2 and get value of 6, and then add 6 with 5 to get value of 11. So that's how the cumulative sum is working, where we are just looking at one value from column A in this case. But to really explain a window function, we have to look at the rolling method that we are going to use. So here if we set the window to 2, then in case of the first row where the A has a value of 1, there's no value before 1, so we get NN if we do a rolling sum. However, now when we move to the second row, we have 1 and then there is 3, so there is a value 1 above 3, so we can add these two to get a value of 4. And similarly we move on, then we take this 3 and add this 2 to it to get rolling sum of 5, and finally we have 2 plus 5 is 7. So that's how the rolling window works, where we specify the size of the window. In this case it was just 2. If we had 3 instead of 2, then we would add 1, the first 2 would be NNs, and then for the third row we would have 1 plus 3 4 plus 2 6, and that would be the value here. So that's what a window is and a window function is. In this video we'll talk only about this. In next video we may talk about windows that are in signal processing. Those are completely different than what we talked just now. Let's get now into Jupyter notebook and start coding. Here I've already created a new Jupyter notebook and imported 3 libraries: NumPy, Pandas and Matplotlib. For data, for now I've just created one data frame that you see here with 2 columns, A and B. The column B has some NN values in it, and let's go ahead and run these 2 cells. Okay, so the data frame that we have looks like this with 10 rows in it. Now first what we are going to do is look at how to use the cumulative sum. If you are not sure about how the statistical parts of these work, I'd highly recommend that you check out the previous videos, in which previous videos on descriptive statistics, where we go in much detail as to how the quantities are calculated, and for all the statistics we are going to talk in this particular video. Here we are going to only do the implementation part in Python. So for cumulative sum in the data frame df, if you go ahead and create a new column, a underscore cumsum, and then is equal to df of a, and then here we just type cumulative sum, and that would create a new column where there is a cumulative sum added. So we can check that. So 1 plus 2 is 3, then 2 plus 3, 3 plus 3 is 6, and 6 plus 4 is 10, and so on. So that's cumulative sum. Next, let's look at, there are similar functions we can calculate, and some of them are cumprod, cummin and cummax. So cumprod would be similar to what we saw above. So I'm going to go ahead and copy this line, and this would be cumulative product. And for product, instead of addition, we are doing multiplication. So 2 into 3 is 6, 6 into 4 is 24, and so on. So that's how the cumulative product works. Similar to this, there is cumulative min and max. So the min would find the smallest value and the max would find the larger value. So in this case, it's going to be 1 only, because if you look at the cumulative minimum between 1 and 2, it's 1. Then again you will this 1 and this 2, it is 1, and then between 1 and this 3, it's again going to be 1. So therefore that entire column has 1. Similar to min, we can also look at cumulative max. Cumulative max would work in the same way, where here we are going to look between this 1 and 2. The max is 2, so 2 and 3, the max is 3, and then 3 and 4, the max is 4, and so on and so forth. So that's how the cumulative methods work. Next, now look at how the rolling works, and there are several interesting ways we can use the rolling function. So for rolling, the very first one we are going to try is creating a sum using the rolling function. So if we create a new column, a underscore roll, and rolling, we give it a window size of 2, and we are going to calculate the sum. So df of a dot rolling, and the open parenthesis, here we type window is equal to the size of the window, we are specifying 2, and then close parenthesis dot sum. So this will calculate the rolling sum of the column A and save it in this particular column, and that's what we see here. So the first is NN, because there is nothing above this value 1 in the column A. However, in second column above value 2, we have 1. So the rolling window would include the row 1 and row 2, and the sum of 1 and 2 is 3, and that's what we see here. Similarly, for the next value of 5, we are adding this 2 from column A with this 3 in the same column A to get a value of 5. Now, apart from sum, let's see how the counts work in this rolling window scenario. So if we create a new column, df underscore count, and here if we want to count the number of non-NANs, so df of b, we'll use the column b because it has NANs in there, dot rolling. Again, if we specify the window is equal to 2, and then put a count there. Now we get a column here which has the counts of non-NN values within that window in column B. So if we look in this case, this is just 1, so we place a 1 there. However, for the row 2, we have 10 and NN, so NN is ignored, so the count is 1. Similarly, now for this one, the reason why this is 0 is because for this the window would have values this NN in row 2 and the NN in row 3. So since both are NNs, both are ignored, and we have a count of 0. However, if we scroll down here, now we have 2 30s. So if we look at this particular 2, this is 2 because we have counted this 30 in row number 8 or at index 7, and this 30. So these are 2 counts that are not NNs, and therefore we have output value of 2 here. Moving on, let's see how we can calculate the min and max. So we'll use the same column A, and we'll create a new column A underscore min, that will have the minimum values. So df of a, and we'll use the this time for rolling window, let's change the value and give it a window of 5 and calculate the min of that, and look at what values we get. Now for a underscore min, here, right here in the middle, we can see that because the window is 5, the first 4 rows have nns in there because it does not have 5 values to calculate from. So as soon as the window has 5 rows or 5 values in it, it calculates the mean, and in this case for the min would be 1 because the 1 is the smallest. From 1 2 3 4 5, 1 is smallest, and then for the next we have 2 because the window has now shifted 1 down, so we have 2 3 4 5 6 and we have the value of 2. Similar to the rolling min, we can calculate a rolling max, and for the rolling max, as we can see here, it works the same way. The first 4 are blanks. However, for the 5th row we have 5 because it is the max value. When we look at the values within the window, 1 2 3 4 5, so the max is 5, and then for the next 2 3 4 5 6, the max is 6, and therefore we have the value of 6 here. Moving on, now let's look at how we can calculate the standard deviation. We can also get the mean. So let's go ahead and try to calculate the mean first, and just so that we can check, I'm going to change this size to a window of 2. Now here, as we can see, this is the last column we created, a underscore mean, and the first row has nn. That's fine, we know because the window just has 1 value. Now once the window has 2 values, we get 1.5 because 1 plus 2 divided by 2, 1 plus 2, which is 3, and 3 divided by 2 is 1.5, and that's why we get 1.5 here, and so on for these values. So 2 plus 3 is 5, divided by 2 is 2.5. Now next, let's look at a standard deviation. So the standard deviation that we calculate with the rolling here is a sample standard deviation, and if you remember from the descriptive statistics videos, the sample standard deviation is the unbiased version where we divide by n minus 1, and if we can also go ahead and calculate that. So I'm going to go ahead and change this to 3. So here 3 here we get a value of 1, and if we calculate this by using the numpy method, np.standard, and let's say we have the values 1 2 and 3. Now if you do this, you get a value of 0.816. The reason is because that is the biased version. So for an entire population, if you want results that match what we have up here in the rolling standard deviation, we have to specify DDOF is equal to 1. That calculates the unbiased version, which is for samples, and therefore now we get a value of 1 that we see in the data frame above. Moving on, let's look at how we can calculate variance. So variance is we use the same method. Again, if you do not understand what variance means, I suggest looking at the previous videos on descriptive statistics. In variance is just a spread of data, so what is the variability in the data we have. So because we have only 3 values in the window, we are getting a value of 1 here, but if we have more values, these would be more interesting. For example, if we change this to 9, then we get 7.5 as the variance for these 2 rows. Now let's move on and look at some other examples. For this we are going to need to create a new data frame, and we are going to look at skew, kurtosis and quantiles. And this is something that we have discussed in the descriptive statistics video, so I'm hoping you'll understand what happens in the background when we type the code. So for I'm going to create a new data frame that has skewed values. So for this we need to import a library which is scipy.stats, and from this we are going to import the skew norm. And now we'll go ahead and create a data frame df2 which is pd.dataframe, and here the column A would have the skewed value. So skew norm dot rvs, and then here we specify how skewed we want the data to be, and then the size, so the number of rows we need there. So if you type df2 dot head, we will get the values. And just to see how the data looks, I'm going to go ahead and plot this. So df2.plot.kde, and this is how we see that. We can also go ahead and plot the histogram if we want to. And as you can see, there is a skew to the data set on the right hand side, so there is a tail on the right hand side. What I mean by that is, if we were to plot, let's say, to copy this and paste it here, and instead of this, I'm going to give it a value of 0, then plot.kde, and run this. Okay, because this has to be a series, so pd.series, and now if we plot this, okay, as you can see in the plot above, that's a kind of normal data set. However, here the data is shifted, so we have this tail on the right hand side, and therefore it's the right skew data set. And if you look at the histogram also, we can see that the data has shifted to the left, and we have long tail on the right hand side. So to calculate the skew, what we are going to do is create a new column, a underscore skew, and for this the syntax is similar, df of a, df2 of a, because we have this another data frame, and dot rolling window is equal to, I'm going to specify a very high number, 998 dot skew, just because it's going to calculate a lot of values and we don't need to see all of them. So when we print df2, we get these nice values for the first 5 and the last 5 rows. So here we can see that the skew is calculated for that window of 998 values from the column A in this data frame, similar to skew. And if you remember, the positive value of skew indicates that the tail is on the positive side, so on the right hand side, as we see in this histogram right here. Now, similar to skew, we can calculate the kurtosis, and here we can see that the kurtosis is calculated right here, and the values are much less than 3. So this could be considered as a more flatter distribution, like a platykurtic distribution. And so that's what we have for kurtosis. Now, in addition to this, we can calculate quantile. And for quantile, again, the syntax, everything is the same. We just change the quantile word in the tag, and the reason for this error is because we haven't specified what quantile we want. So we have to specify the quantile here for rolling, and I'm going to specify 0.50, so that would be the median, and these are the values we get for all the values in the window that is of size 998. Here if you specify q is equal to 0.5, it gives an error. So I'd suggest just putting value of 0.5, and that is working just fine. Now, in addition to these quantile, kurtosis, and skew, we can also use the rolling window to calculate covariance and correlation. So I'm going to go back and use the DF data frame. So DF data frame now has so many columns. We'll use the column A, which has numbers 1 through 10, and here if we use the just those columns 1 to 10 for A and B, and we calculate the rolling of with a window of size 3 and calculate the covariance, then we can see that there's plenty of NNs in there, and the reason is because we have a lot of NNs in this particular column B. Now for the covariance matrix, we get this covariance matrix right here, which is 1, and this is the variance, and then covariance is 0. This is having a lot of NNs, therefore we are not able to clearly see these, but if you calculate the covariance directly without rolling window, for example this dot covariance, here you get a nice matrix that has the values in the diagonal values here are the covariance, and these are the variance. Now I'm going to go ahead and change this to say 10 and run this again. Now in the last part we have this value of 9, and the reason why we have these as NNs is because this COV covariance is looking for 10 situations where there are values in both A and B, and that's not happening because there are NNs in the column B. Similar to covariance, we can also calculate correlation. So we simply need to change the COV to CORR, and here we get the correlation, and I'm going to change this to just 5, or maybe just change this to 3 so that we see some matrix. So we are not, and that's because the data frame has column B with NNs. Why don't we go back? I'm going to go back up and copy this data frame, bring it down here, and remove some of the NNs from this. So I'm going to delete these. We don't need all these values. So I'm going to keep just 5 values in there. So we have those and we have these. Make this 31 and maybe make this 88 and change this to df3. Now if we look at df3, we have this, and here if we go ahead and calculate the rolling variance, so df3 dot rolling window is equal to 3 dot covariance. Here we get nice matrices like here, here, and here for each of the windows. Okay. Similarly, if we calculate the correlation, we can see nice correlation values calculated here for each of the windows. Now after this, I just want to mention that when using the rolling and cumulative functions, these are very helpful when you are trying to analyze sometimes chronological data as well, and you can also create windows by a specific column or a specific time window, and we are going to look that in the next video. Sorry. I hope that was it for this video then. I hope you have learned how the cumulative product, sum, min, max is implemented in Python, as well as how the rolling windows work in Python. Thank you. Please like, share and subscribe. I hope to see you all in the next video.